that is available for a free 30-day trial. Use it all you wish for those 30 days. If you purchased product from us recently, that product comes with you for free. All you need to do is register it by giving us a call or an email. We've kind of developed a chart, for lack of a better word, a matrix of where our products are used and how university classes fit into this. We, of course, have many sections in the average manufacturing plant where we either product design development, new product introduction, production itself, and then machine maintenance. And we've developed the THQM classes, or class, which maps into those, certainly the first three, as well as the machine maintenance area. There's a little bit of overlap into that. THQM being our thermal quality management program, we'll talk about in just a minute. The the classes themselves, ECD University, also map into these various areas of your production floor. We are working with MAP 201 today, where we cover mostly the portions from new product introduction into production itself. That's where MAP 201 is centered, relative to the average product development area of production. Chances are our main goals, certainly with regard to profiling, the main goal is to reduce the scrap and, of course, as a result, increase your yield. And that's why we developed the Thermal Quality Management Program, which is a document, in a sense, a checklist divided into three parts. The requirements part of soldering, where we define what the requirements are in order to get a good soldering job done. That's the why do we profile part of things, where we must understand the heat-sensitive components on the product and the solder technology. Both of those set limits or requirements on how we reflow solder our product. Then the stage 2 is characterization, where our goal is to set an oven recipe to meet those requirements. We must assure that all solder joints experience the required thermal profile. Just like cookies require a certain recipe in an oven, solder joints require a certain thermal profile, a time versus temperature process to make sure that they are soldered correctly, which is, of course, a function of the alloy itself and the flux that is used to suspend that alloy. And then finally, we want to make sure that sensitive components did not experience any damage through that thermal process. And then the third stage of THQM is collecting data. The how are we doing part of this. So many people say, my inspector asks me, how do I know my oven is controlled? Is my oven in control? Do I have any information regarding the control of my oven? And I tell them I've got lots of profiles of product. Well, that's the characterization phase of things in stage 2. But to know ongoing how your oven is going, you simply have to collect data. And that's what we call the verification phase. We're basically assuring that the temperature profile developed during characterization is being repeated over time. And it is ultimately the proof that our oven, our thermal process, is in control. That's the heart of THQM in about 3 minutes. Our agenda today is introduce 2 more of the 5 wizards that exist in the MAP software, the creating of a Target 10 spec, and then the verify process wizard. We'll look a little bit at data extractions, some profile setup options, and then finally the preferences section as time allows. MAP, as you may know, is an acronym for machine and assembly and process. We used to jokingly refer to it as the initials of the first names of the people who developed it, which it kind of is. It's Michael, Alan, and Paul. However, we really were thinking of machine assembly and process when we named it MAP. We will be looking at these 2 wizards, the Create Target 10 Spec, where we're creating a specification from a specification file from an existing data run. and then using that target 10 spec to run what we call our verification process, which also allows the OK button to be used on the mole, or I should say the MegaMOLE or the vMOLE itself. These are 2 of the 5 wizards we have, including the Fresh Start wizard, starting from nothing, Tweak Existing, starting from a profile you already got, and then the third one, which is a simple, just download the data. I don't care about all this other stuff. I want to see the numbers for those of us that get in a hurry. Keeping in mind that the machine assembly and process information can be added to a set of data at any time. Machine and assembly and process information is what it takes to make a complete data run, as we call it now. So, creating a target 10 wizard. As I mentioned, I'm going to be jumping back and forth between software, so bear with me as I accomplish that here. This is the map software. I'm going to get rid of the clock. First off, any questions? You can type them in or you can ask them straight away. Let me unmute you just for a second. Any questions at all what we've covered so far?
Not on this end.
Okay, thank you. Moving right along. Again, feel free to type one in. I'll do my best to catch it on the corner of my screen here. The wizard's creating a target 10 spec. This is a little bit difficult to understand, so I'm going to try and do my best to help you get a feel for what creating a target 10 file is all about. There are 2 ways to get to the wizards. There's a wizard menu, and I suggested creating target 10 spec is the one we're going to show. You can also hit this start button, which you get a separate dialog here. This lists all of the wizards as a set of buttons you can enter. Your 2 types of target 10 specs you can create. I am going to do the one called creating a target 10 spec using an existing profile. The oven checker has come along more recently. That's going to be subject of another class. The steps are the same, but it's for a different tool in that it's for the oven checker as opposed to your product. Let me close this up. I'll work strictly with the menu here. So we're going to create a target 10 spec using existing profile. The purpose of the wizard is to take a profile that you've done. Chances are that you've done with a mole that has lots of channels. In this case, what you were just looking at was a profile done on a circuit board using all 20 channels of the new MegaMOLE. But in the verification process, and by the way, that 20 channels may have been run during the NPI phase where you wanted to know a lot of information about many areas on the board. Once you've identified parts on the board, and with 20 channels it doesn't take you very long to do that, once you found the channels that represent the extremes on the board, maybe the coldest and the hottest soldering parameters, you can narrow down the verification process to a select few channels. And so you don't always have to run all 20 channels with a 20-channel mole in order to verify that your oven is in control. What you want to do is set up a target 10 spec file that probably uses fewer channels. Or certainly you can set up a target 10 spec file that uses fewer channels. You can use all 20 if you want, but you're welcome to use fewer. So to that end, I'm going to set up a target 10 spec file, and the question is, for what instrument are you setting this up? There we have 3 moles in our arsenal. I'm going to set it up for a vMOLE. vMOLE, where the V stands for verify, it's a perfect candidate. It has 3 channels, and I'm going to use that to verify a process that was created using 20-channel mole. So you select your instrument that you're going to use, that you're creating the target 10 spec for, and move on to the next. Next is to choose which profile that you're going to verify. This is the profile you've previously run. The profile I was just looking at before I started the wizard is the one that's selected by default. You can see in the background here all 20 channels. that were taken off this board. And that's the one I'm going to verify. I'm going to do that 20 channel profile. I'm going to verify using a 3-channel MOLE, and I'll show you how that works in just a second. So you run down and you select which profile you wish. The profiles that you have to choose from are those that are in the working directory you currently have open. That working directory in my case is the path and name is our sample one for the purposes of this class. Your directory path and the name of your working directory will be displayed up here in the title bar. I'm going to choose, it's already highlighted for me, I'm going to choose this particular profile. Along the way it also shows me the circuit board picture, just as a reference. It shows me where all the thermocouples were connected all over the place here. And so that gives me confirmation that I'm choosing the right board. Next, you need to decide of the 20 channels that you use to create this original profile, which 3, because after all, this is this V-MOLE, only has 3 channels, which 3 are you going to use to do your verification? That's done in this area here. And as you can see, all 20 channels are listed here. Which 3 are going to use? Now, if I had been thinking ahead, I would have already chosen which 3. I'm going to randomly pick 3 just to move on with the demonstration. However, let's say I'm interested in this Q145, and I'm going to assign that one to channel 1 on my V-MOLE. You'll notice these drop-downs only show 3 channels because the verifying channel or the verifying instrument only has 3 channels, as I said. I'm going to assign this component to channel 2, and I can pick any other one I wish. I'm going to, again, choose components that represent the low and high of my original profile. And of course, an examination of that original profile will allow you to decide which those 3 channels are. It's best to choose the profile channels from that previous or the original profile that represent the lowest temperature curve and the highest, because if those all are within spec, you want to make sure that those 3 remain in spec at all times for verification process. So I've assigned these 3 channels, channel A1, Q40, 145, C235, and finally Q113 onto channels 1, 2, 3 of the verifying instrument. And you hit next. What this shows you now in the background is these are the 3 channels of the 20 that I selected as the ones I'm going to use to do my verification. It's important when I go to actually run this circuit board through the oven again to do that verification that I connect those 3 channels and only those 3 channels to my verifying MOLE, in this case the V-MOLE. And here they are labeled here, Q145, C236, and Q113. So those 3 channels of the 20 need to be reconnected to the MOLE and made ready for a verification profile. At this point, I have 2 choices in addition to just moving on. First, I can see from the green just how good these 3 channels were at meeting my specification. It's a 5.5 out of 10. Remember, this is whether we're in spec or out of spec, so it can be anywhere from 0 to 10. The closer to 10, the closer to the middle of the spec it is. But as long as it's not outside the spec, it's perfectly good and therefore green. If I wish, I can modify the target 10 spec. In doing so, it sets that dialog aside and gives me an opportunity to modify the specifications, that is the limits, the highest and the lowest, for slope, the soak time, the time above, and the peak. Currently, those limits are shown here. If I'm happy with these limits, I don't need to modify them. I don't need to change them. But if I choose to, I can click a button and I can change it from 3 to some other value. Now it's 3.2. And I can do that for any of these specs. These specs originally come from the solder paste that you've chosen for this particular data run, the solder paste that was used to run the data run in the first place. So this gives me a chance to alter those specifications if I wish. The resulting target 10 number with those new specifications will also be shown. In this case, my selecting 3.2 over 3 didn't affect the number worth mentioning, so it's the same. If I'm going to run right out to my solder machine right now and run this VMOLE through with connected to those 3 channels to these 3 parts on the board, I can send that specification to the mole at this point. Or I may just say, I'm creating this target 10, I'm going to save it, I'll use it later. I'm going to choose to do just that, save it for later. So we hit the finish button. It gives you an opportunity to name this target 10 spec we've created. It defaults a name to that which is selected in your preferences, which I'll show you a little later, what choices you have in the way of a default name. I'm going to choose to call this map 201. Oh look, I've already got one of a similar name from last time we did this class. Let me just add enough here to make it different. Okay, you can name this target 10 anything you wish. Chances are you may want to name it the circuit board that you're actually creating the target 10 for, but you can name it anything you wish. I'm going to name it something that I can recognize when we go on with the demonstration. When you hit save, that file is saved in the target 10 specification directory, and we can recall it later. And now we're back to the original profile we were looking at, and a target 10 file has been created. Any questions about that? The concept is always just a little bit difficult. Let me unmute you guys just in case you have a question. And thank you for the chat saying you don't have any questions. That's good. The purpose.
I have a question.
Yes, go ahead, please.
Are the needles indicative of straight up and down needle 10?
Yes, these gauges here represent, in this case, this particular profile. It represents how good each of these parameters, slope, soak, time above, liquidus, and peak, of all 20 channels now, there are 20 of them down here, it represents how good it was at meeting or being within the exact center of this spec range. In this case, for the ramp, 3 to 6 degrees per minute. For the soak time, 60 to 90 seconds. For the time above, 60 or 80 to 100. And for the peak temperature, 210 to 245. So if this needle was straight up, it would mean that you were exactly between the center, or exactly within the center of the spec, exactly halfway between 210 and 245.
Okay, thank you.
And so on. Okay, and our connection to GTM has messed up my drawing here, but I will fix that. Our GoToMeeting always messes up our drawings. All right, so that is the purpose, that is the target 10 spec wizard that we just ran through, and it created a new specification using only 3 of these 20 channels as a target to meet. So the next logical step is I'm going to use that target 10 file as a specification for a verification process. And that takes us back to our wizard menus, the second agenda item, and that is to do what we call verify a process. Verification process says use a target 10 specification, of which we have several, to confirm or verify that the process we originally created in the characterization phase is being met. In this case, I have a handful of target 10 specifications. Because my instrument that I'm looking at right now that's connected to my software is a VMOLE, it will only show me target 10 specification files with the extension T10 here that have been set up for VMOLEs. If I created one for a SuperMOLE Gold or a 20-channel MegaMOLE, I would see those in the list if that's what was connected. VMOLE's connected to my software, so it shows me VMOLE target 10s. I'm going to choose the one we just got through creating. Here's the name of it that I gave it. You may recall. It's automatically selected by default. I could select others if I wanted to. So next you go. And what that does is it says, all right, you want to use that target 10 spec, I'm going to send it to your mole. And it's doing that right now. It takes just a minute or just a few seconds. And then it runs right out and communicates with the mole, and it asks, hey, are you ready to do the job of soldering? Or I should say, verification of a solder process. I have thermocouples connected to this mole, and it noted that, well, it's 29 degrees C in here. You're within your calibration. Here's the target 10 spec I just sent to the mole. You may recall its name, current date and time, logging information, serial number, and so on. If one of my thermocouples was bad, because the thermocouple was damaged or somewhere along the line, I'm going to hit this button here. Let's take a quick look. I would have come up with this type of response. This response saying, look, I got an open thermocouple here. Stop. Something isn't right. And of course, that which is red is showing you what's not right. So you can right then, before you run this thing through your oven and find out that you had an open thermocouple, you can know that your thermocouple is fixed. You hit refresh again here, and it comes back and it says, look, you've done a good job of fixing your thermocouple, whatever might have been wrong with it. Beauty of this is you know that you've got a decent battery. You know that your temperature is right inside your mole. You know you've got your channels hooked up and they're working before you run off, send it through the oven, and find out that one of these things was wrong. So this is your verify process instrument status to make sure you're really ready to go. Next, it gives you the oven recipe. This recipe came from the profile you chose to verify. Automatically was transferred to this. So now here's the recipe setting that was created in the oven that soldered that 20-channel profile you saw. This gives you a chance to, you can print it, take it to your oven, and make sure this recipe is indeed what's entered in the oven. Conveyor speed was 80 centimeters a minute. Of course, each of the zones laid out here. So this is your double check to make sure that your recipe is set. And of course, you actually go and run the verification process. I didn't have the privilege of doing that here, so I don't have a hot oven that I can go running out to and run this through. I've got a bunch of profiles here that aren't real profiles, but I'm going to download one of them just to complete this. These profiles represent just some junk data I had stored in the mole, but it'll show you, again, basically the process of downloading. After I finish this download process, again, this is just a junk profile. In fact, I'm going to randomly choose one of these. I really don't know what I'm going to get. Let's just do this and it'll be quick. This was not a real circuit board run through an oven. It was just some temperatures I ran in. As soon as you download the mole, it says, hey, what file name do you want to save it? I'm going to save it under the default one. It shows me, well, you didn't meet target. Well, indeed, I did not, because, again, it was a random junk profile. And as a result, it will tell you that, hey, this thing didn't meet the target that you had set. And so when I finish here, it's going to show me the resulting profile, how bad it really was. And, of course, it's just a junk profile, as I say, so not anything really interesting to behold other than the fact that, hey, this profile didn't meet your spec, you get a red flag. So let's go back to our 20 channel example here. Okay, how do you, that's a fair question. It's technically not covered in this class, but I'd like to make sure you have at least an answer for that. Setting the recipe, of course, is a part of the characterization stage of thermal quality management. There is an art to setting to picking an oven recipe, but what it really amounts to is, one, a little bit of knowledge of your oven and how it performs. We have software that helps you create recipes. Expert 3 is one as an example. Map software doesn't generate recipes for you, but it certainly shows you or gives you a means to show you how well your circuit board and your solder joints behaved under a given recipe. In this case, this recipe is, as you see here, I selected these values, shall we say, from experience. Experience being, well, the last time I used this oven to solder a circuit board like this one, I used this recipe. And here was the resulting thermal profile. It's well within the specification limits set by my solder paste. I didn't go over any peaks that I'm worried about. I wasn't too cold. My time above was everything I wanted it to be. So this is a good recipe. It might be a good recipe to start with on some new board, especially if your new board is similar to this one in size, in general population of components, and so on. So how is this recipe entered in your oven, and you've run a profile through your solder machine, you can use the prediction features, which is demonstrated in map 101. You can use the prediction features of the software, if necessary, to alter this recipe so that the profile meets the specification. I can very quickly turn on prediction here and just show you what's going on. If this profile, for whatever reason, did not meet the specification, I can now adjust the recipe, and the resulting profile will be displayed here if I change the recipe simply by clicking and dragging these zone temperature values. If my time above wasn't long enough, all right, well, let's turn up the temperature in the zones where it was not long enough, and let's see if I increased my time above, in this case TAL. These are the new values for time above according to these new predicted recipe, or I should say these new recipe settings. This is the predicted shape of the profile, therefore this is the predicted time above. Now as you see, some things went red here. I actually went way over in my time above for using this particular recipe. So prediction is a way of generating a new recipe given an existing profile. If for whatever reason the recipe doesn't meet your needs, you can do that. Any prediction puts it back the way it was here. Let me turn that off. There we go. That is a way of generating a recipe or augmenting an existing recipe. Start with a recipe you know works for similar boards. Predict, if necessary, to alter the recipe as needed. Of usually the solder paste and the components. Components have spec limits. Usually they basically reduce the upper spec of time above, quite typically, and peak. Certain components can't take more than a certain temperature. Or they can take a certain temperature for a certain amount of time. That would be a time above type number. Certain components can only take ramp rates, slopes, less than a certain value. Most manufacturers have set up their components so that ramps don't crack ceramic capacitors anymore and so on, but there's still plenty of them out there that can suffer from high ramp rates, either heating or cooling. So spec limits are usually set based on component requirements and solder paste requirements. You got to get above the liquidus temperature of solder, otherwise you're not going to melt it. If you're using a 217, 221 degree alloy, you've got to be above that temperature according to the solder paste manufacturer for a certain amount of time. And you can't be over the limits of the components. So spec limits are set basically on physical properties of the solder and or the components. It's as simple as that. These numbers, these spec limits, came from the solder paste, and you can alter them if you wish, limit them based on your components that you know are on your circuit board, or you can alter them to make them tighter if you wish, just to hold your solder machine to a tighter specification, just so long as your thermal profile doesn't violate these specifications. You're going to create a good solder joint that doesn't damage your parts.
Flow and all that stuff. I'm talking about how do we set it up in the software? Is that what you was showing us a while ago with the Create 10 or whatever it was? Is that where you actually, if you want your first zone of the oven to be like from 60 to 80, the second zone like 80 to 90, do you have to set that up, or is that automatically taken from the MOLE after you run it through the oven one time? You see what do you understand my question?
Well, I'm going to have to say not quite.
Okay. You got a spec limit of 3 to 6 on your upper and lower for your initial slope.
Right.
Ours might be 1 to 3. Is that something that we establish before we actually run a profile, or do we run the profile first? Then based on what it's given us, we set the parameters after we run the MOLE.
Okay. Well, the answer is yes. In both cases, you can do it either way. Now, obviously, it's best to understand what your maximum and minimum ramp rates should be before you run a profile.
Okay, we know that.
Because the goal is not to see what your machine can do at a particular recipe. The goal is to set a recipe that will meet your need.
Okay.
And the needs are that of the components and the solder paste. They dictate what you should be accomplishing in the way of the shape of a thermal profile. In this case, this particular paste, it said 3 to 6. Now, I may arbitrarily say, yeah, that's really nice, but I don't want anything more than 4 going on here. And you're welcome to do that if that's true, if that's really what you've got to have, no more than 4. Well, that means you got a red going on here somewhere, because one of these, well, in fact, let me just see which one. This one was the worst one. This one was, I'm having trouble reading the screen. This one was like 5 point something. So of all the ones that are here, this was the worst one, going a slow ramp rate of near 5. So I violated the spec that I've arbitrarily chosen here of 4. Now, clicking here opens this back up. I'm going to put it back up to 6. Because that's truly what I can withstand. So now I'm back into the green again. Again, the point is you need to know what the spec is for your solder paste and your components for these 4 parameters, which are twofold. Built into the software for Target 10 tab. You can't change these. And they're built into the MOLE for evaluation of the profile using the OK button. Now, we haven't really got into the OK button. That really wasn't the intent here. But in the creation of the Target 10 specification file, the first wizard I ran, that's where you can set these limits.
Okay, that's what we was asking. I think we're with you now.
Okay, that's where these limits are set. It creates a file that can be loaded into the MOLE for the purpose of using the OK button through the wizard that we call verify process. So here's where you create the Target 10 spec. And of course, you create it from an existing known good profile. And when you create it from a known good profile, it carries with you the oven recipe, and it carries with you all of these spec values that were set for all 20 channels. And it creates a Target 10 file for the verifying MOLE, which in my case was a 3-channel MOLE. I chose lowest channel. I chose the highest channel as the channels I was going to verify using my 3-channel MOLE. And the spec limits, of course, were captured here. And again, you can alter those on your way through that wizard if you need to or wish to. These were the original specs I was shooting for. I made it. I see no reason to fool with those values unless I know better that my component or my solder paste can't withstand it.
That answers my question. Thank you.
Excellent. And I appreciate that question, because is that this is kind of a tough area to kind of get a grip on what we're doing here. We're creating a target 10 spec that can be used in the MOLE to evaluate a profile through the verification process. And the verification process really is twofold. One, I load I have the spec in my MOLE and I run it through the oven and I press the OK button and it says you either passed or you didn't. And passing means, excuse me, let me do some paperwork here. Passing means you've met these specs for the 4 parameters for the 3 channels you profiled. All 3 channels were ramped no more than 6, no less than 3, and time between, time above, and peak. All 3 channels were within these spec limits. You get a green light on the MOLE. You're ready to run. And you can download that profile you took later and see how that looks on the software. You'd especially want to download it if you didn't pass and find out why. And it'll show you why. It'll show you all 3 channels. It will show you these 4 gas gauges, and it'll show you which one's in red, and it'll show you the value and on which channel it occurred, and then you can decide, hey, is this an issue or not? Did my thermocouple come loose? You know, what went wrong? So you get a red, you get an opportunity to download and find out. If you agree at a green, you know you're fine. You don't have to download anything. You're ready to run that product. So those are the 2 wizards I wanted to basically run over, creating target 10 spec and then verifying using that target 10 spec you created. Verifying, again, is something you do over and over and over again, weekly, daily, every time you change the product, whatever, to make sure your oven's ready to go. Let me do some shuffling of, let me get the right one. I want to plow through here, excuse me, while I flip screens like crazy. Get past all these steps. Okay, data extractions. I lost track of where I was going here, so I want to get back to the software. Data extractions is probably the most powerful feature in the MAP software. Previous software, data extractions were pretty much in the can. You get what you get, that's what you can look at. The newest SuperMOLE Gold SBC software lets you create a few data extractions, somewhat limited set under what we call the Kpi tab. If you have the most recent SuperMOLE Gold SBC software, you've seen the Kpi tab. And you can kind of create some custom data extractions. We took that, put it on steroids, made MAP. MAP lets you create any, almost any, certainly any number of data extractions from the profile at your bidding. You can have as many columns of data here as you wish. You don't like the ones that come in with the software, you can right-click on here and punch up delete, and it goes away. So let's say I don't want to have maximum temperature. You just hit delete, and it's gone. And it's gone for every profile you download in the future. It's not gone for profiles you've already downloaded. They got their own table of data. Let's just go up one here. Yes. So here's the table of data for this profile. You notice it doesn't look anything like this one because this data table is for this particular data run. However, removing or altering these columns of data in any way, change it for future profiles by default. Next time you download a MOLE, you're going to get this table set. So we want to create one of our own divining. I'm just going to show you the wizard quickly. You can let your imagination go wild from there. You click Add. Here are the types of data extractions you can pull off a profile. Excuse me. It includes a temperature type data, a value or time value type of data, a slope value type of data, or a temperature delta, or one of the newest features is a speed, which is distance over time, or conveyor speed type of measurement. For the purpose of the wizard, I'm just going to choose a temperature value. There are many options. Oh, let's choose a slope. Let's just go wild here. All right, of a slope type of measurement, there are many types. including the maximum positive slope, the maximum negative slope, the maximum positive or negative. In other words, I don't care if it's positive or negative, I just want to know the maximum. Whether it's going up or down don't matter to me. You can create a slope between two temperatures, a slope between two time references. Time references are these cursors that you can drag around, X references. You can create a slope from a temperature, you choose the temperature, to the peak. Whatever the peak was, it will show you the slope from your selected temperature to the peak, or from the peak to a temperature. In other words, I want to know, basically that's a falling slope typically, from the peak wherever it occurred down to a particular temperature. Or I want to know a zone slope. Within a given oven, or a given oven zone, how fast is it increasing? So you can choose any of these types of slopes. The other cool thing is you can decide whether you do an average slope or a linear regression type slope. Linear regression being, hey, I've got 15 data points between two time values and I want to know the best fit line through those, as opposed to an average which says draw a line from the beginning to the end. That is the average slope. You can also change the size of the ruler you use to measure slope. Slope's a tricky thing because you're talking about how temperature is increasing over time, and when we collect data every so many seconds, once a second, twice a second, 10 times a second. And if you just look between any two data points, like say 1 second, you could get one slope. If you look over a longer set of time, you're going to get a more of an averaging slope. In this case, typically people use a 10-second slope. I don't care about little spikes that may happen in the data between two data points, so I'm going to look over 10 seconds. You could change that to anything you want if you wish. So just for grins, let's just choose the maximum positive slope. That means wherever it occurred on this profile, I want to see it. The next step is to decide if you want to in any way limit where on the profile you wish to look for this slope. You can choose none, which says, I don't care where it occurs over the entire data set, tell me the maximum. That's none. You can choose after the process origin. Process origin is a reference for the oven's zone, or for the oven starting, or the process starting, that you get to pick. You get to move it there, or you can let the software move it there automatically. And you don't care about anything that happened before the oven over here, before you got into the oven. You only care about after. So you can choose after the process origin if you wish. You could choose within a magnified window. I'm going to zoom in on something. I want to slope the maximum slope that took place where I'm zooming. You can choose within the machine, in other words, after the process origin and before the end of the machine as it's defined. You don't care about anything beyond the oven. What happened out in the room after it came out of the oven, I don't care. So you can limit it that way. You could choose within a machine zone, and you get to pick the zone. I only care about the slope, maximum positive slope that took place within a particular zone. And you can get even more interesting between two temperatures. You can pick 0 to 150. Well, that's going to be somewhere in the beginning part of the profile. Or, believe it or not, you can pick between a temperature and the peak, the maximum positive slope that took place between any temperature you choose and the peak value that took place. Just to keep it relatively simple, and you can imagine there's lots of different settings you can do here to restrict where you look for this slope. I'm going to choose after the process origin. Next, you get a chance to format things. You can change the cell color to something interesting. You can change the text color if you wish. You can change how big the font size is, whether it's bold, whether it's centered, whether it's horizontally placed within. So all of that is something you can set. The label is defined for you because of what you've selected in the way of a measurement. So we're going to find the maximum positive slope. Finally, you get to set the number of decimal places. It's defaulted to 3. You can set upper and lower spec limits if you wish. I'm going to set a spec limit of no more than 6. It's an upper spec limit, let's just say. And then it will tell you if you've exceeded that. We hit finish, and now we've got a new column of data here defined as the maximum positive slope. This little one dash line here, and if you notice when I was selecting the what we call the oh, good grief, I want to say restrictions, but that's not it. The area where we confined it to after the process origin, this vertical line was one of the symbols of that one I chose. This indicates that you're looking for maximum positive slope after the process origin, and there are values like 4 point this, 4 point that. Did any of them go over 6? Doesn't look like it. So I've got no red flags in my data box here to indicate that I went over my spec limit of 6 set for this particular calculation. If I place my cursor here for about 2 seconds, it will automatically draw that slope and where it occurred, in this case on channel A3, designated as R224, I got a slope of 4.144, and it's drawing it right here for you. Let me move some stuff out of the way. Let me unclutter this. Let me draw that for you one more time. There's your maximum slope, which took place after the process origin for channel 3, A3, 4.144. So you can begin to imagine how powerful this software can be at extracting information from these profiles at your bidding based on the calculations or what we call content that you can set in these columns. Any questions on that? Let me unmute you quick. Any questions at all? Okay, time's a-wasting, and there's a couple of things I really want to get to. Information about profiles themselves. There's a bunch of stuff that you can choose to show on a profile. You go to the profile menu. Let me cancel this and do that one more time. Profile menu, show on profile, gives you things that you can show on the profile. If you go to profile, show on profile, that shows you all of the things you can show on profile. If you choose either the machine, the assembly, or the process menus, they all have a show on profile choice, but you are limited. Well, I shouldn't say you're limited. You are automatically shown the tab for the machine show on profile if that's the menu you used. If you just want to say, oh, give them all to me, all right, here they all are. Here are the things you can show on the profile itself about the profile. You can show the data run name. That's the name you gave the file when you saved it, or that's the name that the software default gave it if you chose not to change it. Also, you can choose to show the date or the time. In the process of the machine and assembly and process part of MAP, you can show the name of the target 10 specification. I'm sorry, the diagram. That's the name's next. The diagram, which is the nice little funny boxes and shapes that illustrate the spec limits. You can show its name, which shows up over here, and you can show whether the target 10's OK results taken by the mole itself are displayed or not. Again, you can press the OK button, and in doing so, it evaluates the profile for those 4 parameters, tells you whether you passed or not, and creates a number which can be downloaded. Under assembly, well, there's only one thing you can show under assembly. That's the assembly name. That's the name you've given to this particular assembly using the assembly menu, set assembly information. Machines, a bunch of junk you can show here, the conveyor speed, the zones, excuse me, the zone boundaries, which are these vertical dash lines, the zone temperatures, both top or bottom, or both, and the machine name. That's all of this information basically reflects the machine's recipe settings. You can choose to show those or not. And then finally, there's some things you can show about the mole itself. You can show on the profile the battery voltage, the maximum internal temperature, that's all showing up over here, the log interval, and the number of data points in this file. That's all information showing up here. That's information about the mole, and again, that's at the time the profile was taken. It's not current information about the mole. It's information about the mole at the time the profile was taken. So that's basically information about what the conditions were of this profile at the time and date that this particular data run was captured. You can show that or not all over here. One more thing I wanted to get into real quick is preferences. This is a large area with lots of stuff, but I'm going to show you some highlights quickly. I mentioned the name of the file when you download the MOLE and its defaults. They are a function of the preferences under the File menu, Preferences. Profile tab. Profile tab lets you set a whole lot of interesting things. We'll talk specifically about the name of the file. In this case, I have checked the computer name. That's your logon name. I'm sorry, that's your computer's name. That's the name of the computer as set by your IT department or whoever. And the date and time. I could also choose to, by default, include machine information, assembly information, and process information. So if I turned all these on, I'd have a huge long name. But at least I would know the machine it was done on by default, the assembly that I was doing, and the process that I was doing, and on what computer I downloaded it, and the date and the time by default. I can turn all these off and name that file myself. Or I can leave some of them on and add to it myself. When you download the MOLE, you get the choice of renaming that file or selecting the defaults. This is where those defaults come from. Some other nice things to know about the profile is whether peaks are aligned by default. I've chosen to align the peaks of my profile at download time. I can turn that off and never align. I could do the alignment myself manually, but by default, after download, it would not if this were selected to off. I could choose to align to peaks, or I could choose to align to dimensions, subject of 301. I can choose the number of black divisions in my y-axis, in this case set to 4. I can change it to something else if I wish. That's all I need to talk about here. Under Machine and Assembly and Process, there are files that are by default places where you get information and save information. That's 301 stuff. Let me see if there's anything for 201 here. Yes, under the MOLE, for 201 class, we talk about updating firmware. You can, if you need to update firmware, do that. If we send you a file, you can use the update firmware to actually reprogram your MOLE's internal firmware. It's a nice feature to get you up to date if you've got a. That's MegaMOLE and VMOLE only. Things that you can show on the current status: the battery temperature, the connection type, and the user name. That's the MOLE's program username. That shows up down here in the bottom, and you can decide how much of that you wish to see. The reason why we let you turn that on and off is because when it's on, you're constantly interrogating the MOLE. If you don't want to do that, you can shut it off. But basically, you can see right now what my MOLE's condition is at this instant. The battery volts is 4.18. Its current temperature is roughly 30 degrees. I don't know what it's sitting on that's making it so hot, but it is warm. And the connection is USB, and the name of my MOLE is number 1 of 12, Proto. And it interrogates that every, I don't know, 8 or 10 seconds. You can choose your cal interval, at which point, if that interval is up, it will give you a red flag in instrument status. Indicating that the calibration date for this MOLE is up. And you'll get a red flag saying so. In my case, it isn't up, so therefore this isn't red. I'm getting a red flag because all my channels are open. All right. We've got 3 minutes. We very much appreciate your attendance. We very much appreciate your using ECD software and ECD's product, and we want you to be as comfortable as you can be working with it, and that's why we present these classes.